All right, looking up, please. Okay, remember yesterday we learned the rational zero theorem, and the rational zero theorem says that if you have P, your constant, you have Q, your leading coefficient, and you need to write all the factors of these. Yeah, we did. I'm just going to go over it again. Yeah. Okay, so yesterday we talked about how you need to write the factors down. So if P is 9, my factors are plus or minus 1, plus or minus 3, plus or minus 9. Q is 1, my factors are plus or minus 1. And then you need to divide P over Q. So all of them. And again, not tomorrow, on your homework you may get more than 6. But on a test or quiz, because you're not going to have Desmos, the max I will have you try is 6. My advice is always going to be go in numerical order. It will help you not have to do 6. Hint, hint. All right, so we did this one. I'm not going to do this one again for the rest of them. But on the bottom, what happens when your Q is not 1? So again, what's my P here? Yes. Because if you go through, like yesterday when we did this, if you go through these and you end up factoring it out, like in this case, we only had to do 3 because we found 2 of the factors and then the third factor was there, so we only needed to do 3. So if you end up choosing the right ones. And not that it's always going to be the numerical order will do that, but I'm telling you it all depends on what your leading coefficient is. Okay. All right. So for this one right here, my P is 8. What are the factors of 8? Plus or minus, what should we always start with? 1. What else? Plus or minus 2. Plus or minus 4. And always end with the number. What is my Q value here? 3. What are the factors of 3? Plus or minus 1. Plus or minus 3. And on your quiz on Monday, when it says list all possible rational zeros, what am I going to do next? P over Q. Divide them. And you're going to divide all of these P's divided by 1 and then divide them all by 3 as well. So plus or minus 1, plus or minus 2, 4, 8, and then 1/3, 2/3, 4/3, and 8/3.
Are we going to have one like this
on the test, I will not give you one with this many. On the homework, I will. So, are you going to want to sit there and try out 16 different synthetic divisions? No. On your homework, what do you have access to? Don't use ChatGPT. Use Desmos. Go find your zeros. Can't you just put it in the calculator and then get the zeros? On your homework, when you know what the zeros are, just plug those in and get your synthetic division. Do your synthetic division with those zeros so that you're not doing 16 of them. Does that make sense? But again, on your quiz, are you going to have access to Desmos and AI?
Yes.
No. So on your quiz, I will never give you 16 of them. The max I will give you is 6. Okay? So which one do you want to try?
Minus 8 over 3.
What? No. Let's go easier than that.
Try 1.
Let's try positive 1. Is there a placeholder here? You can do negative 8 over 3. You do that one, Gavin. I am definitely not touching that. Yes, but again, am I going to give you this many on the quiz? Absolutely not. 6 goes by really quick, especially, yeah, I'm just going to say that. Is this a 0? No. What's the next one we want to try? -2 is a great choice. These should take you about 30 seconds each. So what do we notice? -2 works. Now remember, now that we have -2, we are going to use this depressed polynomial. No, it's not sad. It's just smaller. Use this depressed polynomial to check your other ones. What's another number we should maybe try? 4. Great. Awesome selection. So I'm now going to use the depressed polynomial. Besides it's smaller, why else should I use the depressed polynomial? Because it's going to end up factoring it for you if you do it. 4 is a 0. So what are my factors here? What's my first factor we got? No. Factor it out. What is this going to be?
Oh,
X plus 2. What's the next one that worked? X minus 4. And what was I left with? 3x minus 1. So what are my zeros? -2, 4, and 1/3.
You stop because it's a...
I stopped because that's another factor. Right?
Well, I mean, like, you don't do more zeros if it's a cubic, right? So if you add more factors, it would be higher.
Correct. This is a cubic, so how many possible rational zeros are there? 3. There wouldn't be more than that. Because remember last homework we talked about the number of rational zeros was based on the highest exponent. We stopped. Yeah, because on the last example, if you look up real quick, we ended up with x squared minus 3. If you were to factor that, do you agree that's a difference of, I guess that's not a square, but you could square root it? Where did we end?
We just at the 0 equals 0, therefore -3. We didn't do -3 though, that's the thing.
Oh, we only did 1?
We did the 1 and then...
Oh, we didn't finish yesterday?
We did 1, -1, and the +3.
And did +3 work out?
No.
No. Okay, so that's why. We should have kept going yesterday. I just clearly was in the middle of whatever was going on in that room up there. Okay, so we did -1 though?
Yes.
Okay. No, I did something wrong just now. Oh, why did I put -4? I think I did that yesterday, didn't I? Okay. -1, 3, -3, -3. There we go. +3, -9, +9, 0. Okay, we did that right there. Okay, so that's why y'all are confused. Okay, so -3, we got to keep going. We need to use our depressed polynomial. Oop, not smeared. So I'm going to use 1, 3, -3, and -9. So my factors are x plus 1, x plus 3, and what's left right here? x squared minus 3. And if you were to make x squared minus 3 equal 0, what would you get for your zeros? The square root of 3 and negative square root of 3, because you would get plus or minus square root of 3. You could. Yep. But again, what is my exponent right here? 4. So what is the number of possible? I do want to caution you, though, it's not always going to be that same number because they could have some imaginary zeros, which we'll talk about on the next page. All right, so a word problem, you are going to get a word problem like this. A word problem is not much different. There's just one little bitty thing you need to remember. So the number of video games that were sold by a company on the release day can be modeled by that equation, where g of x is the number of games sold in hundreds, and x is the number of hours after the release. How long did it take to sell 400 games? 400 games is which variable? G of x. However, is g of x going to be 400? Why not? It's hundreds. So what is g of x going to be? Just 4. Does that make sense? I am going to set this equation right here equal to 4, because I want to find out how long it took, which is how many hours. That's x. So what do? Subtract to make it equal 0. And then what? Louder? What can I do now? GCF. What's the GCF here? And I can actually just divide both sides by 2. Because there's no x with it, so it kind of just goes away. So x cubed plus 2x squared minus x minus 2 equals 0. Now I have what? How do I figure out the solution? I'm going to do my p and my q. My p is negative 2. What are the factors of negative 2? And q is 1, so we get plus or minus 1. Here's the only difference with a word problem. What are we dealing with? What are we talking about here? Time. So you can't have a negative. So instead of when I divide p over q to find my possible answers, should I even look at the negative answers? No, because is it possible to sell 400 games before the release? No. So my only options to look from are the numbers 1 and 2. So who wants to try 1 out and who wants to try 2 out? Let's see which one you pick. Who's the winner? I'm going to do both for the sake of proving it to y'all. So how many hours did it take them to sell 400 games? One hour, because that is not going to be the answer. So your answer is 1 hour. Questions? You could, but yeah, you totally could. But either way, you shouldn't get it. It's not a 0. Only one of these should work out because it wouldn't make sense for them to sell it at 1 hour and 2 hour. So I just use the original one for both. Yeah. All right. Last but not least, I want to talk about the fundamental theorem of algebra. So just as quadratic functions can have real or imaginary zeros, polynomials of higher degrees can also have zeros in the complex system. This fact, combined with the fundamental theorem of algebra, allows us to improve our statement about the number of zeros any nth degree polynomial. So, if you go back to page, I think it's 3. Yeah, if you go back to page 3, over here, we had this equation right here, and it was the number of possible real zeros was 4. But whenever we factored it out, all we got was -2 and 2. There were only 2 real zeros. But, do y'all agree x squared plus 1, if I solve that out, I would get plus or minus I. So it only has 2 real zeros, but it does have 4 zeros altogether. Just 2 of them are imaginary. So, the fundamental theorem of algebra states a polynomial function of degree n, where n is greater than 0, has at least 1 zero, real or imaginary, in the complex number system. The corollary to that is a polynomial function of degree n has exactly n zeros, including repeated zeros, in the complex number system. So remember when we learned the beginning of January, remember we did the little bubble with our complex number system? Right, and we had the big bubble. Wasn't everything a complex number? You remember that? Some of them were complex, non-real, and some of them were real. So, when a polynomial equation in one variable with real coefficients has a root of the form a plus bi, everybody circle that, where b is not equal to 0, meaning it is complex non-real, then the conjugate is also a root. Meaning, if you have one zero that's not real, you actually have 2. It always has a pair that is the conjugate. You can use this theorem to write a polynomial function given its complex zeros. This was all a really complicated way for me to show you this right here. This right here says, write a polynomial function of least degree. This is how we're going to approach it with you. In factored form that has these zeros. So, the first one should be easy. What do I need to start out with? F of x. Did y'all forget f of x yesterday on those? What is my first factor going to be? X plus 2. What is my second factor going to be? Okay, real quick. Why did you put plus 2?
Because it's negative. So.
Technically, do y'all agree this is x minus -2? And this is x minus whatever that is right there? So if this is 3 minus I, what is my factor going to be?
3 plus
The whole factor. X minus what? 3. So it would be like minus 3 minus I. Because isn't that technically what we did here? X minus 4, x minus -2. So we're going to do x minus whatever this is. What is x minus 3 minus I? X minus 3 plus I. So that is the actual factor. But what did I just tell you about if you have an imaginary root? There is also the conjugate you have to do. So this also has x minus 3 plus I, which gives me what? Y'all tend to try to do the plus or minus in front of the 3. The plus or minus goes in front of the I. Do y'all see that? Be careful when you're doing this. A lot of people make mistakes on this. And so I'm just going to rewrite it right below. Take your factors, and if I give you an imaginary factor, you always have to add its conjugate as the other factor. It's always going to have one more. I'm going to do one more right above it, just like in that little blank.
Are we going to have to like do anything with that? Or just
Nope, that's your answer. Just like you had over there, like what I said, just like we did over here when I said, hey, these are the zeros, write the factored form. It's the same process, just you have to know that if you have an I, you're going to have 1 plus I, 1 minus I. That's all I
meant, like, are we going to have to do this and then like do anything with like synthetic division or something like that?
That's all we're doing with this. Or we're solving it out like we're doing on this last one. It says find the complex zeros of this equation right here. Use a graphing calculator to help decide what numbers to try as your possible rational zeros. What's my P right here? Negative 75. Are you really going to want to sit here and do all the factors of negative 75? No. What's my Q here? 1. My Q is 1. Could I do all the factors of negative 75 and then divide them and figure them out? Sure. We don't have time for that right now. I'm trying to save us time. So on a homework, if you get a question like this, what can you just do? Go plug it in Desmos and look it up. All right. Let's try again, going in numerical order helps. Let's try number 1. Are there any placeholders here? Looky there. Now we're going to use this depressed polynomial. What other numbers should we try? Two's not a factor. 3. Let's try negative 3. And again, use your depressed polynomial. I don't hate it, as long as I can follow it. Oh, looky there. And what do you notice about my depressed polynomial here? So what are my factors here? Hold on, start with the one we started with. X minus 1, what else? X plus 3, and then what am I left with here? X squared plus 25. Which means my zeros are what? 1, negative 3, and what happens if I make that 0? I get x squared equals negative 25, which is what? Plus or minus 5i. So what are my factors here? I mean my zeros here. $5i and negative 5i. On your homework, I think at one point it asked for linear factors. Is this a linear factor? Do you agree that's a quadratic factor? How could I rewrite this as a linear factor? You would write x minus 1, x plus 3, and then what would you write? X plus 5i, x minus 5i. And all of those are linear. You have about 25 minutes left in class. You have homework due when you walk in on Monday. Your homework's going to be due. We are going to trade and grade, and then you are taking a quiz over this on Monday. So I think the calendar is wrong about that. Yes. This one right here? Say it, like, when do you know to do that? This one and this one right here? Yeah, come up here. The only time you have to do this down here is if it specifically says find the linear factors.
I don't even know how to ask a question.
Yeah.
Because you have to do like
this,
like twice every
versus
single time.
what?
Versus this one. This one is only one.
Well, no, you would do this twice, but we found the answer right away. You would do this until you found the answer.
There's sometimes you only do one.
Over here, I gave you the factors, and you're just checking the ones I gave you to tell me yes or no. Where over here, turn it over. Over here, I didn't give you anything. I'm saying find them. And that's where you have to check them until you find them. I didn't make you check them until you find them because just for time. And if it's something like that many, put them in the calculator. Yeah.
But on the quiz.
On the quiz, I'm going to give you max this many. But don't forget to write your P over Q because that's how you find these numbers.
Okay.
Yep. Yes.